Hi, my name is Joel, and I work with Debarshi and Vikram. Today we are going to discuss method and equipment recommendations for optimizing weed removal and planting processes at a rain garden. The main objective of our project is to optimize the efficiency in regards to weeding and planting in the rain garden. The site of our study was a local community rain garden in Ann Arbor serving the surrounding area. We had roughly 20 volunteers on site at the time of work, and the volunteers varied in age from college-age students to older Ann Arbor citizens. The purpose of the work performed at the rain garden is to purify water of the surrounding areas, as well as improve aesthetics of the park. The overall duration of the work was 2 hours. In regards to the weeding process, our primary goal is to optimize the distribution of the overall workload of the process, evaluate the current procedure with MODAPs, and find opportunities for improvement through SketchUp. Additionally, we are concerned with reducing the biomechanical stresses of each worker. We also have plans for reallocation of work in order to optimize the efficiency of the weeding process. For planting, much of our goals overlap with weeding, but we additionally plan on introducing the specialization of roles since there are many sub-processes within the overall planting process.
Here is an overview of the current process at the rain garden in SketchUp. Volunteers were split into 2 groups of 10, with 1 supervisor per section. Each side encompasses a space of about 100 by 100 square feet. The top dark brown area involved removing weeds from the unfinished garden space, while the bottom area had volunteers digging and planting native plants. After 1 hour, the groups would switch sides. For the current planting process, volunteers were separated into planters and diggers. Diggers would first drill a hole into the ground with a drill and auger attachment, and then the planter would use a hand trowel to finish the job and cover the plant with soil on the outside. However, there were only a few drills provided, so some volunteers used a hand trowel to accomplish both tasks. Occasionally, a supervisor would come by to monitor progress. For the current weeding process, workers were provided gloves and were told to scavenge the unfinished garden space for weeds. There were trash bags provided to deposit the picked weeds in. A few issues that immediately arose was the arrangement of volunteers in the garden space. Weeds were scattered around the area unevenly, and it was difficult to hand carry the weeds back to the trash bags every time. Here is an overview of the future process. By using SketchUp, it was easy to visualize where some important changes could be made. Volunteers and supervisors have been moved to evenly distribute the workload. For the future planting process, you can see the volunteer with the red shirt has his hand trowel and shovel replaced with a long shovel. This will aid him when digging into the soil without bending. In addition, the supervisor has now been placed in a central location, overseeing all the volunteers, and is equipped with a Kanban board to delegate tasks. The board should have 3 categories: waiting, work in progress, and finished, so volunteers know exactly what to work on and how long each task should take. By understanding what tasks to focus on, this will help eliminate as much non-value added time as possible. For weeding, we recommend that volunteers are separated into even quadrants so that each person has an equal workspace. As you can see from SketchUp, they are placed on a 3x3 grid. Wheelbarrows are used to efficiently take all the weeds to the trash can at once, and garbage bags are placed in all 4 corners so each quadrant can easily get to them.
For our MODAPs analysis, we condensed the original weeding process into 4 sub-processes: walking to the weeds, bending down and getting the weeds, walk towards the trash bag, and put weeds in trash. The original weeding process takes 17.36 seconds with a total of 134.60 mods. In our planned improved process, we changed the process by utilizing the tools of a stand-up weeder and a wheelbarrow. This would reduce the overall amount of biomechanical stress utilized, as the workers will no longer have to bend down to pluck the weeds. Also, this will reduce the overall amount of walking after plucking, as wheelbarrows are stationed near them. Additionally, we delegate a specialized role of pushing and discarding the remains in the wheelbarrow. After data analysis has been performed, we believe we can see a 10.18 second improvement in overall time per process iteration.
For the planting process, we found that the total mods for an individual planting a single plant was 148 with a total time of 19.09 seconds. For a planting recommendation, we suggested the use of a long shovel to dig the holes to reduce the physical strain that would otherwise exist from bending over the planting area. We also suggested delegation of tasks so that the total amount of time and effort exhibited by each person was less, as shown in our MODAS breakdown. Our average mods per worker was 43.67, with an average time of 5.63 seconds and an overall process time of 16.9 seconds. The three main limitations that we identified were weather, single volunteer event, and extended processes. For weather, we said that since the weather now is very cold, icy, and snowy, there are no rain garden volunteer events for us to observe. As a result, much of our analysis was based on the data we got individually from the original rain garden event in September, in which the weather was 70 to 80 degrees. For the single volunteer event, we said that since we couldn't collect current data, most of our process analysis was based on a single rain garden event from September. And for extended processes, we said that the rain garden event was composed of multiple procedures and processes, and as a result, we had to narrow down our focus and limit which volunteer processes would be within the scope of our project. Thank you for listening to our presentation. Any questions, comments, or concerns?